Obi-Wan Kenobi. You're my only hope.
Her name was...
Hi, everyone. This is Mrs. Lansford. I wanted to check in about the assignment that I had posted last week. So for last Star Wars Day, May the 4th, I had posted an assignment to Google Classroom asking about a meme that I had seen pop up around the internet that day, and a lot of times that day. And it got me thinking, is this actually mathematically correct? So I have a little replica of the little R2 unit. Ooh, exciting. And I was going to walk through the math right now. So if I look at, if you can see my screen, ooh, this is the meme that had been popping up all over. So if you can see, ooh, got a little lightsaber too. It said the area of a circle is pi r squared, the volume of a cylinder is pi r squared h, and the volume of R2D2's head is then volume equals r squared d squared, R2D2. Mind blown. But the question is this really true? Which, when I first saw it, I was like, oh my gosh, that's amazing. I wonder if that's actually true. And being a good mathematician, we never just believe things that we see or read. So that is what we're going to be doing today, looking at, is this actually possible or not? So the first thing we think is, what shape is R2D2's head? And many of you noted that, you know, we're not given that. That's an assumption that we have to make, but it certainly does look like half of a sphere, right? And, oops, and can it equal r squared d squared? So that's my question here. And so we know that for a sphere, the volume is 4/3 pi r cubed. But obviously his head is not the entire sphere, it is half of a sphere, right? So, which implies a half sphere has the formula volume is equal to 1/2 4/3 pi r cubed, which is the same thing reduced as 2/3 pi r cubed. Okay, immediately that doesn't simplify to R2D2, so, or r squared d squared in this case. So let's pause for a moment and think about, what would it take to get these two things to be equal? When can this equation be equal to that equation? So that is what we're going to answer now. So I kind of take myself on a side note. We'll go, ooh, look, side note. And we'll say, when is R2D2, r squared d squared, equal to 2/3 pi r cubed? That's good to know. So that's what we're going to do. So we look at this equation. We immediately see that there's r's on both sides. So I'm going to go ahead and divide both sides by r squared. And I can do this as long as r is not 0. Which, safe to assume, his radius is not 0. So we're going to get d squared is equal to 2/3 pi r. Okay. Another thing to note, and many of you did in your submissions, at some point you know that the diameter, which we assume is what this d is referring to, is equal to 2 times the radius. And I've got a 2 there and an r there. So I'm going to substitute that in. And I'm going to get d squared is equal to 1/3 pi times d. D. 1/3 pi times d. All right, getting somewhere. Now I notice there's d's on both sides. So I'm going to go ahead and divide both sides by d. Again, assuming that the diameter is not equal to 0, which I think is safe to assume in this case. So then I get d is equal to 1/3 pi, which I'm going to write as pi over 3. Interesting. Huh, okay. So that means that if d is equal to pi over 3, then this equation should work. So let's go ahead and see if we can get it. So we said that the volume of a half a sphere is 2/3 pi r cubed. But I got to plug in for what I know. And so I'm going to rewrite this in a slightly different way. See if I can. This becomes pi over 3 times 2 times r squared. Ooh, does everyone follow that? So I notice that the pi over 3, so I'm just taking that top form and kind of spreading it out a little bit. That pi over 3, we're going to let equal d. And then I notice that this 2r, because of this same principle that the diameter is always 2 times the radius, I can say that 2r is equal to d. So then in this case, I have that v is equal to d times r squared. Or rewriting that, d times d is d squared. So volume is equal to r squared times d squared. What? That's crazy. This formula actually works? What are the odds? But let's take a moment and think about what we had to assume in order to make this equation true, right? We had to do a little math magic, and we had to assume that d is equal to pi over 3. Well, what is pi over 3? Let's take a moment and think about that. So if d has to be equal to pi over 3, well, pi is 3.14, so pi over 3 is approximately 1.05. So that's just a number, right? So the only time this formula works is when we assume that d is equal to 1.05, which is a very specific number. So it absolutely does not work in all senses of that. So this begs the question, is this one particular instance the instance of our friend R2? So in this case, we need a little bit more information. So I'm going to go to a browser, and I am going to type in I'm going to type in R2D2 Dimensions and tell me to figure out what are the actual dimensions of R2D2. And if you notice, just a quick Google search tells me that R2's diameter is between 18 inches and 18.5 inches. So the real diameter, the real diameter is approximately 18 inches. So not the 1.05 that we were hoping for. Maybe we're in a different unit, right? Maybe this diameter is in terms of feet, right? But then 1.05 feet is just over 12 inches, which is still not quite correct. So although it is fun, it is a punny meme for sure, not accurate in terms of the math provided by this example. So I hope you've had fun. I hope you got some good thinking out of it, good researching out of it. Shout out to Kevin for the 2-page essay he wrote me on the ridiculousness that is this meme. I thoroughly enjoyed it and appreciate the thought that went into it. Thanks for playing. Bye, guys.